All right. So when you take the absolute value of the whole function, it would end up looking like this and this, right? Whole thing goes up. Now, here's the original. What if I did the absolute value of just x? What does that do?
Same on both sides.
It leaves the right side alone. So whatever you have on the right side, doesn't matter if it's positive or negative, whatever you have on the right side stays put. And then it gets redrawn on the left side. And what was on the left side is no longer. Remember that from yesterday? Okay, so we're ready, I think, for number 4, right? And we're gonna talk about the stretches and the shrinks, and then we're gonna start putting it all together and practice drawing some of these random things. All right, so here we go. Our shape that we're starting with is, looks like just a little semicircle. That's our basic shape. And the first transformation says this. Well, it's gonna get bigger or smaller. It's gonna, when you start putting multipliers in your problem, that changes your size. Remember, adds and subtracts change position, but multipliers change your size. So how is this affected, Marin?
Wouldn't it kind of stretch like wider? Not like it would be, I don't know the right word.
I mean, that's a straight stretch wider is, I mean, I understand what you're saying. That's an appropriate way to say it. It's not what happens in this problem, but it could, it will happen in some problems. Sydney?
So because it's on the, it's not in the parentheses, it's applied to the y, so the y value would be half, so it would be shorter.
It applies to the y. It applies to the y. F of x is a y. So we're saying we're gonna take half of the y's. That's exactly right, Sid. So the width of it is gonna stay exactly the same, but the height of it now is only going to be 1. So it's just shorter. A number in this location multiplies the y. So it's half as tall as it was. Brain?
But so, when it's saying y equals 1/2 f of x, is that, like, if it was saying y equals 1/2 and then x was in parentheses, would that be a completely different function?
Y equals 1/2 x is just a straight line.
So is the f, like, what is the f of x in this situation representing? I guess that's what
This picture right here. This is f of x right here. So we're taking that picture and multiplying the y's by 1/2.
Okay.
So in the next question, oh. Be careful. What do you think is gonna happen here? First of all, is anything gonna happen vertically?
No.
There's no number out here in front, right? So whatever this is, it's still gonna be too tall. What's gonna happen, do you think?
Shrink.
George?
It's gonna be half as wide.
That is exactly what you think should happen,
2 times.
but it isn't what happens.
Oh,
Because when, I want you to, George, just think back to like everything you've ever done. So, for example, when you have a little quadratic, okay, and you factored it, what are the solutions? are the x values here?
-2 and
Okay, so when you look at it, it says +2, but it's really not, it's really -2. Think about when we were graphing these things and we had to graph y equals absolute value x plus 1. What happened to this picture? It's a +1, but which way did it actually go? It actually went left. When you do stuff to x, it's the opposite of what you think it should be. So this number, George, is actually going to divide the x. It doesn't multiply by a half, it divides by a half, which is the same as timesing by 2. So this is actually going to be twice as long or wide, that, sideways, as the original. It's the same height, so 1, 2, 3, 4, 5, 6, 7, 8. It's the same height, but now it's twice as wide. It would half it, that's right. So whatever this number is, Chris, if it's multiplied by x, you divide by it. And since it's a half, dividing by a half is timesing by 2. So, a number out in front multiplies the y, a number inside divides the x. That's going to be so important when we start graphing our trigonometry. So try to remember that rule right now. All right, everybody good? Okay, so now I got another random weird shape on here. Looks like a little trapezoid. Okay, and a triangle. Now, I like to just kind of take note. The original picture is this one, the trapezoid part, is 4 wide and 2 tall. And this guy is 4 wide and 3 tall. This might help me as I'm going through. So here we go. First one says, sketch. This is f of x right here. This is our f of x. So we're going to put it 2f of x minus 1. So we're saying the y's are going to get doubled.
And x has been moved to the right.
And we're moving over right 1.
1.
So however you can get that put together, that point's not at the origin anymore. Now it's over here at 1. And it's still, is it still 4 wide?
Yeah.
Okay, but instead of being 2 tall, now it is
4 tall.
4 tall. So I'm gonna recreate the shape, 4 tall and moved over 2 to the right, or 1 to the right, 1 to the right. Now, is the triangle still 4 across?
Yes.
But now it's 6 deep. And the point that it did end at what, -4, but it got shifted, so now it ends at -3, right? Everybody okay with that? Isn't too bad. Try the next one. See what you can do with the next one. Remember to go back to the original now. You're going back to the original picture. started by doing the absolute value of the whole function. I kinda did it in dashed lines there. Is that right? For the absolute value?
Yeah.
Now, what do I need to do to it?
Shift it down
Take
to,
it down to, so every point is gonna come down to, how does that blue thing look? Does that look okay to you? All right, try C on your own and let's see if somebody will come up with it on the board for us. By the way, what do negatives do? Flip
multiply.
things, that's right, so you're flipping all over the place here.
For the absolute value one, I drew mine the same way down there, but I don't understand why that would be the right picture because there's like, it's all negative.
This is positive,
Yeah.
but when you subtract 2 from it, can you be negative? What's 1 minus 2? So when you didn't take the absolute value of the whole picture, that would have to be positive. You took the absolute value and dropped it down to. The order you do stuff matters. Sammy, you got this done? Let's see what you got. All right, let's give Sammy a yay or a nay when he gets it up here. What do you think about Sammy's picture?
Looks good. That's what I got.
Did you
Oh,
have?
that's what I got.
Well, then it must be right, right? If it's what Sammy got? Yes. What's happening in this problem? Can somebody tell me what this negative right here does? What does that negative do?
Flips the Y.
So it goes across the x-axis. Now, it changes the sign on y. But when you change the sign on y, don't you go across the x-axis?
Yes.
Okay, upside down. What does this one do? Changes the sign on x, which flips you across the
Y.
y-axis. So basically what Sammy and all of you had to do was you had to take this picture and turn it upside down, which meant that the trapezoid is now below and the triangle is above. And then you had to flip-flop sides. We put the triangle on that side and the trapezoid over here.
So when it's inside the parentheses for the X, how does it need to be what you think it won't be? Like,
Oh, that's a great point. You're literally changing the sign on X. So, I mean, that immediate, so what was positive 1 is now negative 1, so I don't know. You're right, Lennon's theory breaks down there, doesn't it? But it's across the y-axis. Good. It doesn't matter, you're good, you're good. All right, number 6. Consider y equals x squared. Apply the transformations in order and write the resulting function. So a horizontal shift 2 units to the right, vertical stretch by a factor of 3, vertical translation 5 units up. So see if you can write, like this right here. This took the absolute value and translated it down to. So this is the equation. Now you're doing it for the equation x squared. So take a parabola and do these things to it. What would that equation look like? Okay, so what did you say, Chris?
Y equals x squared minus 2.
That would be
In
y.
parentheses.
It would have to be parentheses x minus 2 squared.
Okay, so what have we accomplished there? What did that do?
Shifted it 2 units
2
right.
units to the right. Now, a vertical stretch by a factor of 3. So in other words, you want to multiply your vertical by 3. So where do we put a number if we want to multiply the vertical?
Right after
Right after
both equal.
There it is. And then a vertical translation 5 units up. How do we do that?
Add 5 to the end.
Add 5 to the end. Absolutely beautiful. All right, can you sketch it? Quick sketch, you got something that looks like that? Probably remember from last year, when you put a number bigger than 1 out here, it makes your parabola skinnier because it's literally stretching it vertically. So it's pulling it up, making it skinnier. All right. Ready? Apply the transformations in the opposite order. So do number 3 first. See, when we wrote our equation, we did in that order. Now go in the other order.
I have a quick question. Why wouldn't it be x squared minus 2 inside of parentheses? Why would it be x minus 2 and then c squared?
Okay, Marin, what does that do to a picture?
And move it up and down.
Is that what we want to do?
No, but why wouldn't you put that x squared minus 2, like, just put parentheses?
You can put parentheses around it. What's that going to do to your picture? That is not going to move it right. That does not, that takes x squared and drops it down to.
But it's still.
You know what she's saying?
It's
I
about
know,
the
I
order
was
about
thinking, like, since that 2 is still inside of the parentheses, in that situation, why would it change it?
Okay, this is taking x squared, which is a parabola, moving it down to. This is not moving left or right. This is taking your x before you build your parabola and moving it 2 units to the right, and then building the parabola. So here you are moving and then making your parabola. Here you move your parabola and then you are moving it. Okay. What have you come up with? Did I come up with an equation here for in the backwards order? All right, vertical translation 5 units up.
X squared plus 5.
That would be what she's talking about, right? So we're gonna start with x squared plus 5. Right?
Yes.
Vertical stretch by a factor of 3.
Put the 3 on the X.
Okay, but now, we've already moved it, right? And now we're stretching it.
Would having it throughout there affect the vertical translation?
It sure is.
So it's
And then, a horizontal shift 2 units to the right.
Maybe you need to factor out the X squared. So like,
Wait,
take the X squared and do X squared minus 2, and then end parentheses plus 5.
That's
That
what
has
she wanted you to put minus 2 here.
like 3 parentheses x minus 2.
Could you
and
not just write 3x squared plus 5? Or is that different?
Well, let's talk about that. We're supposed to be doing this in order. So what is the first thing we're supposed to be doing?
Vertical
So
translation.
now our new problem, this is our new function now. That's our new function right there. Okay?
Wouldn't the 3 also apply to the 5?
Well, it would, and that's
Wouldn't
gonna
it be
change that
15
point, and
more?
I don't think I wanna change that point.
So would you put it 5 over 3?
So wouldn't you,
These need to be different though.
Would it be 15? Would you distribute it?
Were you?
Yeah, you would distribute it. I'm trying to think graphically though, does that make sense? Because, okay, so I've got my parabola moved up. Now I'm supposed to apply a vertical stretch
Could you not just write the 3
to that parabola.
3 only applies to just the 3x squared now with parentheses? Or
Yeah,
that
can you
would-
not just write the 3 times x squared?
Yeah, just don't add the parentheses.
No, here's what I want you to think about though. The vertical stretch is supposed to apply to the y coordinates, right? So it's supposed to take all the y coordinates and times them by
Would
3.
you do 1/3 y?
Well, yeah, that becomes 3
oh
on the
no,
other
you
side.
do 1/3 x.
No,
That stretches the x.
no. Guys, listen to me. Okay, so I have this parabola drawn, right? That parabola is drawn. Now, it says a vertical stretch of 3. That means every point on the picture is gonna be 3 times as tall as it was originally. That's what a vertical stretch means. Now, if you're starting at the origin, then will a vertical stretch impact the vertex? No, because it's 0. And 3 times 0 is 0. But if I am applying a vertical stretch to these y coordinates, then that's actually gonna move this thing. Because now I have to take every y coordinate and times it by 3. So it's gonna be skinnier than it was, and it's gonna be 3 times as high as it was before. So when I had my picture drawn over here, you know, these wacky things like this, nobody had any trouble taking that point and making it twice as tall. Right? That's exactly what I'm doing. I'm taking a point and making it 3 times as tall. So now I've got a parabola that's 3 times as tall as it was. Okay? Now I have to figure out, so I'll just call this 0.15 now. Now I have to figure out how to shift it 2 units to the right.
Wouldn't you just add +2 after the parentheses?
Out here?
Oh,
Okay.
no,
So
never mind,
tell me
never
about
mind,
that.
never mind.
What would that do?
Move it up.
Change the
y.
That's gonna take it up even more, right? So I don't think that's what I wanna do. What do you think, Oliver?
Could you do 3 parentheses x minus 2
What?
parentheses squared and then plus 5?
Well, yeah, but I
You
think
just
that-
like rewrote the whole problem.
Does that work?
No, he just right here, he made that x minus 2.
Well then,
Where's the 2?
I thought
So
we
Two
just
units.
order would be the same.
Oh, no, they're not the same.
Oh.
The whole point of the
Oh.
problem is to show that they're not the same.
Oh, I thought the whole.
Is that
thing
correct?
was
No,
just like,
the whole point of the problem is to
open our
show
minds
you
and like, oh,
that
it's easier.
order matters.
Oh.
Order matters,
That
okay?
makes more sense.
Now, our job, stop and think about this, our job was to take this guy and move it over here to this to the right, right? So let's go back to this picture right here. Would this equation, would this equation accomplish that? So what will this do?
Move it 2 units
So
to the right.
in the beginning, it's just gonna move it over to here, right? And then it's going to, then we're gonna have to do what? Watch the parentheses. We're gonna have to add 5 to it. So now this is the point, instead of being 2, 0, now it's at 2, 5. And then we have to times it by 3, and that would make it 2, 15. Now, that picture and that picture are different, obviously, because the order I do things matter. Yep, Lucy?
But I'm confused why the 15 would be correct if you're only supposed to move it 5.
What now?
The 15 would be correct if you're only supposed to move it 5.
Well, you're supposed to move it 5, but then triple the height. So the y coordinate's 5,
So tripling the height affects the, okay.
affects the y coordinate.
Okay.
Right?
Mhm.
So that, I think, is the thing that's causing us the most confusion, and we really need to get that straight. You need to understand that a number out in front of the function, whatever the function is, x squared or whatever it is, a number out in front multiplies every single y coordinate. Now, if the point, you got points on the x-axis, then those are zeros, and 4 times 0 doesn't change that. But any other point, whether it's negative, maybe this is 3, -5, okay? Every other point, if it's not on the x-axis, every point is going to be times by 4. So that point is going to move down to 3, -20. Every y is times. Whether it's a vertex or not, doesn't matter. So your point then was, oh my gosh, when I did it in this order, then I initially started out moving up 5, but I ultimately ended up moving up 15 because the whole verticalness of the problem got tripled. All right. Okay, let's look at number 7. It's another weird shape straight out of your textbook. Yep. Where the what? Who's talking to me? Where the 2 is. Oh shoot, oh no, here it is. Because in order to move everything right, I have to subtract 2 from x. But it is in the middle of this problem, because it was the last thing that I did.
Miss Ford, why wouldn't it do 3 times the -2 at some point? Like, how come the 3 doesn't change the x squared at all? What's stopping it from being 650?
Okay, I'm trying to think of an example here. Okay, so let's just look at this. This would be the parabola, 2 units to the right?
Yeah.
Okay, so if I put a 3 out in front of it, that's gonna make this a 3, and it's gonna make this a 12, and it's gonna make this a 12, right? But fundamentally, these numbers are different, but isn't fundamentally that the same thing as this?
Yeah, you just,
So even though there are other numbers in there, so what you're saying is if I distribute this, that stuff is gonna change? Yeah, it is, but when I factor it, it's gonna be exactly the same. And I need it in its factored form
yeah.
in order to know where it sits.
Okay.
Okay, so I would never distribute it anyway, but if I did, it's okay, I would just factor it back to get it in that form. careful, because when you stretch something vertically, you can think of that as compressing it horizontally. Because think of me as a short little stocky person, okay? If you could grab a hold of my head and pull me up, then what's gonna happen to my stockiness? It's gonna get skinnier. So the act of making me taller automatically makes me skinnier. And likewise, making me fatter is gonna make me look shorter. So I'm not getting all hung up in the word. A vertical stretch is a vertical stretch times 3, right?
Yeah.
But if you want to describe that in some other vocabulary, I'm fine with it. I'm not. I'm going to say vertical stretch. Okay? Yeah, we need to get going, guys. These are all good questions, but you need to get in here and maybe just practice a little bit more to see how it all works. Let's look at this next one. What is happening here? All right, so wait a second. Let me get a copy. Don't be confused by the order of the problem. If you would rather have this +2 back here, you certainly can. Also, you guys are really smart people, so you can maybe do all this at once. There are three things happening here. What are we doing?
Moving it to the left.
One, 3
Vertical
times as
stretch.
tall, and up 2. Now, if you can do all that at once, that's great. I tend, when I do it, to do one thing at a time. So, but it's up to you guys. I mean, whatever works for you, that's what I want you to do. I use a colored pencil to kind of help me keep straight. So I'm gonna go left 1. So if every point goes left 1, every point left 1, let's see, where's that last one? -2. Alright, so there I've got my left 1. Now I'm gonna make it 3 times as tall. So instead of going down to -4, it's actually gonna go down to -12. And up to okay, so my purple is this. I've moved it left 1 and multiplied the height by 3. Notice these points don't change. Why? Because their height is
0.
Timesing it by 3 isn't going to change it. Now I've got to add 2 to it. So my final answer is going to be blue, because we're a blue ribbon school.
What does that mean?
That's a good question.
It's actually a really big deal.
What does it mean for you?
So every point's going up 2. It means we'll be the envy of everyone.
It's crazy.
People will hate us even more. But there it is. So, my lowest point is at -10. I don't know if I counted right or not. And my highest point is at 8.
Wait, what's the picture on, just like the picture that we originally have? What's just the function for that?
That's just it. That's just some random function. That's f of x.
Okay, that's
F
like
of
the
x.
base.
Yes, that's what we're starting with. Lucy?
Does the blue point, not the, okay, wait, the one I'm trying to describe, is that 1 of, is it 1, 2, or -1, 2?
This one is.
Yeah, okay.
Negative 2 tenths. And 3
Or not high.
Alright, here we go. What's happening in this one? Again, you can do it. If some of you like to just do it point by point, do all of it, that's fine. What are the changes you're making?
Right or
Left.
left
You're going
one.
left one, you're going
Over the
upside down,
Over the line,
and then up one.
up one.
If you follow the normal order of operations, you'll never go wrong. So do the parentheses first, then do the multiply, then do the add, then you can get it done. So here we go. I'm going to take my original picture and I'm going to move it left one. All right, so left. All right, now upside down. All right, so I went left one and upside down. And now I'm going to go up one. So the pink is my final insert. I went left one, I erased that, then turned it upside down, and went up one.
Oh.
Alright, come on, we gotta get through these next two, here we go. What's this one gonna, what's gonna happen with this one?
You're gonna make it 1/2 as one dash.
It's gonna be half as wide as it was. So over here in the original, the triangle is 4 across and 2 tall.
Now it's gonna be
Well, now it's gonna be 2 tall, but only 2 across. And this thing going down was originally over 2 and down 4. Well, now it's gonna be over 1 and down 4. That's it. All the X's got half. Divided by 2. This number right here
you need that.
divides X. So all your X's got divided. All right, one more. What's happening in this one?
Vertical's red.
We're gonna go 1
To the
right, make it
Vertical.
twice as tall, and then pick it up 2. All right, let's get it done. Alright. Try going right one. Alright, so there's right one. Now twice as tall.
Yes, you can go up 4, and then you go down by 8.
So my black was right 1, and my blue was twice as tall. Remember, this means multiply the y's. So -4 becomes -0. 0 stays 0, but 2 becomes 4.
Now,
And then we'll move everything up 2. So now we're at -6. And +6. So my pink is my final answer. Got it?
yes.
I want you to get out your 1-6 homework. You've already turned it in, it's fine. And we're gonna do one problem together. So either from one, we're gonna do a sketch in number 1 or a sketch in number 2 together. So look at those, look at the different transformations. Which one would be a good one for us to do together? 2 what? A or B? B? Alright, let's do 2B. Here we go. Doing it together. If you've already done it, kind of check with us, make sure we're doing it right. Fix it if you missed it. Here we go. Now, the original picture, I keep track of what that looks like. Alright, so the original picture looks like it's 2D and 1, 2, 3, 4, 6 white. And then this guy's on 2. Is he 5 tall? I think he is.
6 2.
He is. Don't try to confuse me. I'm confused now. Okay. So he's 5 tall and 6 wide. Alright, so that's my original picture. Now, tell me what I'm doing here.
Taking the absolute value.
Of just X.
Just X.
So when we take the absolute value of just X, as long as X is positive, I'm looking at X's now, as long as X is positive, nothing's gonna change. So I'm gonna redraw that trapezoid exactly the way it appears in the picture. Because when I take the absolute value of something positive, it doesn't change. I know some of you are looking at this and saying it's negative. No. What am I taking the absolute value of?
X.
X. These X's are positive. Right? Now, what happens on the other side?
You mirror it.
Mirror it. I love that word. You mirror it. It mirrors to the other side. So there, this is the absolute value of this of X. This picture, taking the absolute value of the X's, produces this. Now, all I need to do is move it how?
Down one.
So every point is coming down 1. It's not changing its size or anything like that. It's just coming down 1. So that's what it should look like for problem B. That's 2B. Okay, quicker, maybe we can get 2A done, since I've got my picture up here. What's happening in 2A?
It's the absolute value of everything.
Okay, so we're taking the absolute value of the whole function.
And then,
Okay, so now what that does is, if it's negative, it becomes positive. So that's gonna flip that up. Same trapezoid, and now it's up. And what's it doing to the triangle?
nothing.
Nothing. So this is the absolute value part, right? Is that all there is? Yep. Now, what does this 1/2 do? Divides what by 2?
All the
A
y.
Y.
Y, so the height makes it half as tall. So it's gonna be half as tall. So instead of going up to 5, my triangle's only gonna go up to 2.5. And instead of going up to 2, my trapezoid's only going up to
1.
1. And the blue thing is the answer to that question. So you are certainly allowed to do it in stages like I do, but use a different color. You somehow distinguish which one is your final answer. Marin?
So the 1/2, is, like, usually when it's on the, outside, it'd be like multiplying the y's, so basically it's just dividing y's by 2, because it's
Yeah,
that.
multiplying by 1/2
Okay.
is the same as dividing by 2. The number in front of the y always multiplies the y. So Tess, I would call that a vertical shrink.